Hello! In this lesson we're looking at triangles and congruence. Our essential question is, how can you show that two triangles are congruent? Vocabulary. Congruent. Two geometric figures are congruent if they have exactly the same size and shape. Corresponding angles. When two figures are congruent, the corresponding angles are the angles that are in corresponding positions and are congruent. According to this picture, you can see that the green angles match in color, which means that these two angles are congruent. Also, you can say that they're congruent because they only have one arc on each of these angles. The blue angles are congruent over here because they have two arcs and they're the same color. And the red angles are congruent to each other because they have three arcs and they're the same color. Corresponding sides. When two figures are congruent, the corresponding sides are the sides that are in corresponding positions and are congruent. In this image over here, we can see that this side, which only has one tick mark, is congruent to this side, which only has one tick mark. And this side that has two tick marks is congruent to this side that has two tick marks. And this side that has three tick marks is congruent to this side that has three tick marks as well. Example 1. Naming congruent parts. Write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. Our first step is to write the congruent statement. When we are writing congruent statements, we want to follow a pattern. So we'll take a look at our first triangle, which is triangle ABC. And we'll say that triangle ABC, which goes from 3 arcs to 2 arcs to 1 arc in the angles, is congruent, and we need to follow the same pattern. So we're going from 3 arcs over here, which is P, to 2 arcs, which is Q, to 1 arc, which is R. So we can say that triangle ABC is congruent to triangle PQR. Now let's look at congruent angles and sides. Angles are easy. For starters, angle A, which is in the first position of our triangle ABC, is congruent to angle P, which is also in the first position in triangle PQR. So we can say angle A is congruent to angle P. Angle B is in the second position of triangle ABC, which means it is congruent to angle Q, which is in the second position of triangle PQR. So angle B is congruent to angle Q. Angle C is in the third position of triangle ABC, which means it is congruent to angle R, which is also in the third position of triangle PQR, so angle C is congruent to angle R. For sides, we have line segment AB, which is this segment over here. That is the first and second letters of triangle ABC, which means it is congruent to the first and second letters of triangle PQR, which is this line segment over here. And you can see this line segment AB has 3 tick marks, so does line segment PQ, so we can say that line segment AB is congruent to line segment PQ. Next, let us look at BC, which is the second and third letters of a triangle ABC, which is this length over here. Notice how it has 1 tick mark, which means it is congruent to this length over here, which also has 1 tick mark, which is also the second and third letter of our name of triangle PQR. So we can say that line segment BC is congruent to line segment QR. For our last side, we're going to look at line segment CA, which is our third and first letter of our triangle ABC. CA is right here. Notice how it has 2 tick marks, which means it's congruent to this length over here that has 2 tick marks also, which is RP, which is in the third and first position of triangle PQR. So we can say that line segment CA is congruent to line segment RP. Example 2, using properties of congruent figures. In the diagram, DEFG is congruent to KLMN. Find the value of X, find the value of Y. Let's start by looking for the value of X. I notice that X is part of the variable expression for this line segment over here, which is MN. MN is the third and fourth letters of my quadrilateral KLMN, which means it is congruent to the third and fourth letters of triangle DEFG, which is FG, and so it's congruent to line segment FG, which is right here. Since I know that line segment FG is congruent to line segment MN, I know that the measures are equal, so I can set 5x plus 2 is equal to 12 and solve for x. So we start by substituting 12 for FG and 5x plus 2 for MN. Isolate 5x by subtracting 2 on both sides, and we get that 10 is equal to 5x. Isolate x by dividing 5 on both sides. 10 divided by 5 is 2, so 2 is equal to x, or x is equal to 2. Now let's look at part B, find the value of y. Y is this angle measure over here, which is angle L. Angle L is the second letter of quadrilateral KLMN, which means it is congruent to the second letter of quadrilateral DEFG, which is angle E. Angle E is right here. Since I know these two angles are congruent, I know that their measures are equal, so I can say that the measure of angle E is equal to the measure of angle L. I can substitute 111 degrees for the measure of angle E and 5y plus 6 for the measure of angle L, and solve for y. Start by subtracting 6 on both sides. 111 minus 6 is 105. Isolate y by dividing by 5 on both sides, and 105 divided by 5 is 21. So y is equal to 21, or 21 is equal to y. Theorem 4.3, third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. If angle A is congruent to angle D, and angle B is congruent to angle E, then angle C is congruent to angle F. So those two angles are congruent. Example 3, using the third angles theorem. Find the value of x. In the diagram, angle V is congruent to angle Y. You can see that because angle V has two arcs over here, and so does angle Y. So these two angles are congruent, which means that if angle V is 67 degrees, then angle Y is also 67 degrees. And angle U and angle Z are congruent. Angle U only has one arc, so does angle Z. We know that the measure of angle U is 54, which means that the angle Z also is 54 degrees because they're congruent, and so their angle measures are equal. From the third angles theorem, we know that angle W is congruent to angle X. So the measure of angle W is equal to the measure of angle X. To solve for x, what we first need to do is find the measure of angle W. We know in a triangle, all of the angles add up to 180 degrees. So what we can do is take the sum of 54 and 67 and subtract it from 180 degrees to find the measure of angle W. From the triangle sum theorem, the measure of angle W is equal to 180 degrees minus 54 degrees minus 67 degrees, which gives us 59 degrees. So the measure of angle W is 59 degrees, and we know that it is congruent to angle X, so angle X must be equal to 59 degrees. And then we can set up an equation where 4x minus 5 is equal to 59 degrees using the third angles theorem. Solve for x, add 5 on both sides. 59 plus 5 is 64. Isolate x by dividing by 4 on both sides, and 64 divided by 4 gives us 16. So x is equal to 16. Example 4, determining whether triangles are congruent. Decide whether the triangles are congruent. Justify your reasoning. From the diagram, you are given that all three pairs of corresponding sides are congruent. We know they're congruent because we can match their tick marks. Line segment DE only has one tick mark, which means it is congruent to line segment HG, which also has one tick mark. Line segment GF has 3 tick marks, which means it is congruent to line segment EF, which also has 3 tick marks. So line segment EF is congruent to line segment GF. Line segment DF has 2 tick marks, which means it is congruent to line segment HF, which also has 2 tick marks. So line segment DF is congruent to line segment HF. Because angle D and angle H have the same measure, we know that angle D is congruent to angle H. Since these two line segments EH and DH intersect, we can say that these two angles over here created by the intersection are congruent, and that's using the vertical angles theorem. So we know that angle DFE, which is this angle here, is congruent to HFG, which is this angle here, and that's because they are vertical angles. Since all of the sides in triangle DEF is congruent to corresponding sides in triangle HGF, and 2 angle measures in triangle DEF is congruent to 2 angle measures in triangle HGF, we can use the third angles theorem to say that angle E is congruent to angle G. So all 3 pairs of corresponding sides and all 3 pairs of corresponding angles are congruent. By the definition of congruent triangles, triangle DEF is congruent to triangle HGF. Theorem 4.4, Properties of Congruent Triangles. Reflects the property of congruent triangles. Every triangle is congruent to itself, meaning that triangle ABC is congruent to triangle ABC. Symmetric property of congruent triangles. If triangle ABC is congruent to triangle DEF, then we can switch places and say that triangle DEF is congruent to triangle ABC. Transitive property of congruent triangles. If triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle JKL, then by using the transitive property, which gets rid of the middle guy, which is triangle DEF, we can say that triangle ABC is congruent to triangle JKL. Alright, that's it from me. I'll see you all soon.